Hi, welcome back to McClutchy Maths. My name is Natalie McClutchy and we are continuing our video series today on algebraic techniques with our sixth video looking at dividing algebra. Let's jump straight in with a quick recap. So you would recall from seeing this in primary school, maybe through your maths teacher's lessons, that division can be shown in three ways. So firstly, we could show it using a division symbol. We've seen that before with the little line called the vinculum and the little dots above and below the line representing a numerator and a denominator. So here's an example, 7x divided by y with that symbol in between. We could also show this in fraction form. This also means the same thing, 7x divided by y. We've seen fractions like 3 over 4. It's actually 3/4, but it could also be written as 3 divided by 4. So that little fraction symbol there in the middle is the same as with the fractions with the dots above as well. Typically when we're using spreadsheets, we use a / to represent division, but some textbooks also show a divide with that / 7x divided by y. So be prepared to see questions in textbooks and exams in any of these three ways. However, when we're using algebra, it's typical to use fraction form. It just makes it much easier to simplify. It becomes a good convention rather than using that divided by symbol. So it's a great way once we get into some big algebra terms, particularly algebra fractions down the track, to start writing your division as a fraction. It will make life a lot easier for you, as you will see later in the video. Any number divided by itself is equal to 1. So 30 divided by 30 equals 1, 100 divided by 100 equals 1, and it's the same with letters. A divided by A equals 1, M divided by M equals 1, x squared divided by x squared equals 1. So anytime you divide something by itself, the answer is 1. Students will often say that it's 0. It's not, it's 1. Okay, that's very important to remember. Now, any fraction that we have with a denominator, whether it's the number on the bottom of the fraction, is 1, we typically don't write it as a fraction then. We just write it as a whole number or a numerator. So if I end up with something like 4 over 1, I would just write that as 4. And it's the same with algebra. If I had x over 1, I would simply write that as just x. So for example, here we've got 6x over 1, and we would write that as 6x. Now you might be wondering, well, I haven't really seen 6x over 1 very much. They always write 6x in my textbook, so why are you showing me this as a fraction? Well, when we do some of our worked examples, some of your answers might end up being a fraction over 1, in which case you don't need to write it as a fraction anymore. You just treat it as a whole number. And we're going to look at powers in our future sub-series on index laws. So we're not going to get into powers in this video today, but dividing different algebra fractions using powers is an important skill. So just be aware that's coming up soon. So let's have a look at some of our basic division rules. So any expression you've got, so if you've got something like 6x and then a divided by and then a y, change it into a fraction, 6x divided by y. So that's your first step, get it into a fraction. Then if we're dividing our pronumeral, which is like if it was 6x, the pronumeral is the x part. It's going to be, if it's being divided by something else, it's going to form part of the numerator. So anything, let's say I had a divided by 3, then the pronumeral is before the divided by, which means it goes on the top of the numerator. So here's an example, x divided by 3. When you're setting that up as a fraction, whatever comes first, before the divided by symbol, goes on the top of the fraction as the numerator. And in the same way, if the pronumeral is the divisor, it's the thing that's dividing something else, it's going to form part of the denominator. So here's an example as well. In this case, it's 3 divided by x. So the x part comes after the division symbol, which means it goes on the bottom of the fraction. Okay, so if you can follow these three basic rules, you'll do okay. So let's have a look at 28c divided by 7. So we're going to write that again as a fraction, get rid of that division symbol and simply write 28c over 7. Now you remember from our basic rules from our previous slide that because the divided by is in the middle, the 28 was first, so that's why it is going to be on the top, and the 7 is going to be on the bottom because it comes after the divided by symbol. Now the next thing we're going to do is focus on all of our whole numbers. So our whole numbers are 28 and the number 7. We're going to make sure that we can simplify this fraction doing something called cancelling. Your teacher's probably done a bit of this where they've crossed things out, and you might be wondering, why are we crossing things out? It gets really messy. I'm going to explain that to you in a moment. So it's a method called cancelling that simplifies the fraction. So what we need to do is look at the top and the bottom of the fraction. Let's ignore the c for the moment, the 28 and the 7, and ask ourselves if we can simplify that fraction. Does 7 divide evenly into 28? And the answer is yes. It actually, 28 divided by 7 is 4. So we can cancel the 28 and the 7 out. What we're effectively doing is dividing that 28 by 7, and we're now going to rewrite that as 4c over 1, because the c hasn't changed. It hasn't been divided by anything in particular. The 28 and the 7 were simplified into the number 4. And because we cancel the top and the bottom out, we've divided 28 by 7. We've divided 7 by 7. So 28 divided by 7 is 4. 7 divided by 7 is 1. That's why we end up with the 1 on the bottom of the fraction. Now, as we mentioned before, we don't need to write fractions with a base of 1 on the denominator. We can just write it as simply 4c. Okay, let's do another example. 20ab divided by 2a. Once again, set it up as a fraction. It'll make it a lot easier to solve it. Focus again on those whole numbers first. We're going to do some cancelling out again. So we've got 20 divided by 2. So 20 divided by 2 is simply just 10 over 1, because 2 goes into 20 10 times, 2 goes into 2 1 time. So we're going to write that as 10 AB. The A that's on the bottom stays on the bottom. It hasn't gone anywhere yet. So we've just simplified the whole numbers first. Now we can look at the letters and see if there's any letters in common with the top and the bottom. I've got A divided by A. Now remember I said earlier, anything divided by itself equals 1. So we can actually cancel the A out with the A, and it becomes just the number 1. So I could simply write 10b over 1, or we just write 10b, because when we have a denominator of 1, we don't need to write it. So the a divided by the a disappears basically, because we're now multiplying 10 by 1 by b. 10 times 1 makes 10, so we don't need to write that times 1 in there. Okay, let's look at worked example 3. Now, I often see this kind of question. Students are really tempted to rewrite that as 10xy divided by 5y. But remember, that divided by symbol tells us which order to do it first. The 5y goes on the top, the 10xy goes on the bottom. Now, I see students also, even though they've written that correctly, will still automatically do 10 divided by 5 makes 2, and they'll change 5/10 to a 2. Remember, 5/10 is a fraction. We can actually simplify that fraction, dividing the top and the bottom by the number 5. So 5 divided by 5 on the top becomes 1, and 10 on the bottom divided by 5 becomes 2. So I'm going to have 1y on the top, 2xy on the bottom. Now, you would remember from our previous videos that if we've got a coefficient of 1, like we do on the numerator there, we actually don't need to write the 1 at all. So we can just simply write that as a y. So now I've divided the numbers. That 2 will stay on the bottom, because technically what I've got now, 5/10 is equal to a half. And that's why I had the 1 on the top and the 2 on the bottom. Now I'm going to look for letters that I've got in common with the top and the bottom. I can see a y on the top and I can see a y on the bottom. They are going to cancel out as well. Y divided by y equals 1. Now it'll be 1 over 1 is what we're actually cancelling out to. So, but typically we just write 1 over 1 as 1. So the 1 stays on the top. I don't need to write the 1 on the bottom. 2 times 1 is just 2. And the x stays on the bottom as well. So now I've got half, and then the x is on the bottom. It's not half of an x, it's 1 divided by 2x. And our last example today is a worked example. We're writing an expression for the height of the triangle shown below. Now, we've got the area, it's equal to 18 CD, and the base is equal to 12C. So we've got to find that perpendicular height that runs through the middle of the triangle. And we remember that from our previous video and also from previous work, that area of a triangle equals half times the base times the height. So let's take the information we've been given about the area and the base and substitute it into this formula and see if we can work out the height all by itself. So 18 CD, the area, is going to be equal to half times the base of 12C times this unknown height. So now I've got 18 CD equals half of 12C times height. So if you think about half of 12c, we'll just go back a little bit there, half of 12c is the same as 12c divided by 2. And guess what? That makes 6c. So that's why we can come up now with this new expression, 18 CD equals 6c times the height. Now what we're trying to do here is get the height all by itself. Now this is a little bit complex because we haven't talked about solving yet, and we will in future videos. But to undo multiply, and we're going to talk about this a lot more, to undo multiply, we divide. So we're dividing both sides here by 6c. Now first of all, you can see 18 divided by 6 gives 3. So 3 will be on the numerator. So that will be 3CD divided by C. C divided by C is just 1. So that means we can cancel out the 2 C's and we're left with just 3D as our expression for the height. Now it's always a good idea before you walk away from a worded problem to check your work. So what I would be doing now is looking at that area, and then I'd look at the base and look at the height. If I did 12C times 3D, I would get 36 CD, and if I times that by half, I'd get 18 CD. That's equal to my area, so I know I've done the work correctly. Well, let's have a quick chat about what's coming up. We're going to look at expanding algebra expressions, factorizing them, substituting, solving. Then we're going to move on to index laws, quadratics, algebra fractions. There's so much in this series. I'm so excited to be sharing it with you. If you found this video helpful and it helped consolidate some of those things that you knew about fractions and how that forms algebra terms and how to do cancelling properly, what that actually means, then why not tell us in the comments that you found it helpful. Tell a friend, tell a teacher, tell a sibling, and like and subscribe to us at McClutchy Maths so that you'll always know when fresh videos have been dropped. And if you've got any questions about anything you saw today, contact me at mcclutchymaths@yahoo.com. You can also reach out on Facebook and Instagram. That's a great place to stay in touch and also to add a bit of humour and spice to your day. Well, thank you so much for watching here at McClutchy Maths. I'm Natalie McClutchy, and have a wonderful day.